What is the role of the mitochondria? That's right.
It's the powerhouse of the cell.
If you know that, then you're already well on your way to understanding what we're going to be discussing today. The Krebs Cycle. Number 1. What is it? The Krebs Cycle, the Krebs Cycle, also known as the tricarboxylic acid cycle, is the second step in cellular respiration, following glycolysis and preceding the electron transport chain. It takes place in the mitochondria.
The powerhouse of the cell.
Number 2. What does it do? The stuff that the Krebs cycle the Krebs cycle. Gosh, why do I keep doing that? Anyway, the molecules that the Krebs cycle pumps out are NADH, FADH2, GTP, and CO2. Number 3. How does it do this? This is the hardest part of the Krebs cycle to understand because there are so many molecules and molecular transactions involved. So to make this a little bit simpler to remember, I want you to keep in mind one thing. Pa-okiasphoma. Now, I know what you're thinking, it sounds funny, but it works. Now let's unpack this a little bit more to see what is produced from each and every reaction of Pa-okiasphoma.
So, P, pyruvate, is actually just a glucose molecule split in half. A, acetyl-CoA, is what pyruvate is converted to after it's been split up from the glucose molecule. This acetyl-CoA meets with O, oxaloacetate, to create C, citrate. This citrate is then converted into I, isocitrate, which is then converted into A, alpha-ketoglutarate. And during this conversion, one molecule of NADH and one molecule of CO2 is produced. Alpha-ketoglutarate is then converted into the first S, succinyl-CoA. And this reaction again produces one molecule of NADH and one molecule of CO2. Succinyl-CoA is then converted into the second S, succinate, which creates a molecule of GTP. Succinate is then converted into F, fumarate, which eventually yields the molecule FADH2. Fumarate is then converted into M, malate, which is then converted into O, oxaloacetate, creating one more molecule of NADH. This oxaloacetate meets again with another acetyl-CoA molecule, making citrate, completing the cycle and making it start all over again, hence the Krebs cycle. Now let's look at what we've got. What are the products that have come out of this cycle? Well, we can see that there are 3 molecules of NADH, 2 molecules of CO2, 1 molecule of FADH2, and 1 molecule of GTP. Or if you want to use the shortened version, NFGA 3211. This is what the cycle produces, and some of these components are used later in the cellular respiration process, namely FADH2 and NADH. So remember, Pa-okiasphoma and NFGA 3211.
And that is pretty much all that you need to know about the Krebs cycle. I hope you learned something today, and thanks for watching.